send us wherever they go, and I know they will always remember where they come from. To the glory of Almighty God and advancement of knowledge, I hereby declare this tech fair open. Thank you. Thank you, sir.
Thank you, sir.
We'll be inspecting the exhibits and talk to us. What are you doing?
Good afternoon to everybody. So on this display we have plant tissue culture, which is a system of growing plants using growth medium to help them grow. So these plants grown, the shoots are what is cultivated into the medium. The medium contains MS media, sucrose, and all the nutrients that they require for growth. So this medium is effective for growing plants that are virus-free, basically disease-free. It helps growing from the meristem to develop plants that are disease-free. In this medium, the plants are developed, they grow faster, and then have like higher yield. They mature faster. Yes, that's the right terminology.
Is this in line with this coming thing, or it's another way out?
Plant tissue culturing, yes. So you can transplant them from here to the field, but at first they have to be acclimatized in a screen house because they can't be transplanted directly into the soil. In case of, they need to adjust. So acclimatization in the screen house first. We grow them in grow buckets before they are now transplanted into the soil.
Thank you, well done. Chemical.
That's sir. Yes, my name is Ofebu Awenzi from the Department of Industrial Chemistry, Chemical and Food Science. You can see we're selling soap that was made in the lab. It has glycerin, sodium ethyl. It's a very clean soap and good and very soft on the hand. It's neutral, use surfactant, and very clean, neutral, and helps you to wash your clothes. Can be for washing.
Yeah, I'm sorry. Something happened about 2 weeks ago. Well, last week, my grandmother was washing with some of this soap. Not one of these, but and she started complaining about pains in the hand, and I mean, I don't know. We had to use palm oil to rub it. I hope this is skin free, skin friendly.
Yes, sir, the neutral soap that. Yes, I tested it, sir. The neutral soap, sir. The one she might have used might have been acidic or basic. That's why hand caused her hand to start reacting.
They will need to, so that people will not bite and then go outside and find out it's very.
Okay, sir.
Have you tested it? And
yes, sir, I tested it, sir.
Okay. What are the components you used?
Sodium ethyl, ethyl sulfate, glycerin, and distilled water.
And how much?
This costs 1,000. So the small one costs 650. The small one costs 650. The bigger one costs 1,000. This is 2,000, sir. And for the 5 liters. For the 5 liters.
Okay. How does it compete with those sold outside?
As for the ones
outside, it must be market friendly.
Yes, sir.
How to go on marketing?
As for the ones outside, not to discredit them, we make our own in the lab. We use proper measurements, good and clean equipment to make ours, and everything is done under supervision, sir.
Yeah, the
and
cost.
it's cheaper.
The cost.
It's also cheaper, sir.
Cheaper than theirs?
Yes, sir. Economy friendly, sir.
Okay, thank you. How much is that one?
5 liters is 9,000 tuma.
Okay, all right. He has to go. Okay, thank you very much. So, okay. But 9,000 appears to be a lot. Well, because of the economy, isn't it?
Yes, sir.
Because the pastor should be more than 3,000, 4,000. Okay, well done. I hope we shall start buying this in-house. We don't have to go outside again.
No, sir, you don't have to go outside, sir. Okay.
Where next? Huh? Made by chemists. Okay, the chemists made it, so I recognize them. Ah, yes. How are you, man? Thank you. I think we need to recognize our pressmen of the fourth estates.
Okay, you're welcome, ma.
She has done Bells very proud.
Yes.
We became more visible after the last press conference. Throughout. You want to make some comment, ma? You don't want to?
Ma, for coming.
Thank you. So where are we?
Good day, ladies and gentlemen. I'm at Department of cordially observed. I'm Amzat Fariat. I'm representing the Department of Food Science and Technology. Today we have cookies, cornflakes, cake, multigrain swallow, bean flour, gogi powder, lafu, and fufu. I'll be talking on the function of kunu and the benefit of kunu, malted kunu. Our cereal grains were carefully selected: kiwa, millet, and sorghum. After selected, we cleaned and sorted our grains. After sorting them, we steeped them for 24 hours to enable fermentation. After steeping, it was drained and allowed to germinate. The germination would enable enzymes to be produced to break down complex carbohydrates in the grains. After germination, it was kilned. Kilning is basically drying at a temperature of 70 degrees Celsius. This would enable the flavor and aroma of malted kunu. After kilning, we steep again for further fermentation. After and milled it, wet milling it, which would enable the extraction of the kunu juice from the. After milling it, we sieved it to remove all possible present settled and decanted excess water.
Bring the kunu now.
You can see that is one of our.
Is that the only one?
No. We have more. Kunu, please, kunu.
Bring the kunu now.
Oh wow, sold out. We have.
You sold out.
How can you?
No, ma, we still have more in the lab.
Is it cold?
Yes, more is coming. Okay, kunu is source it locally. Some from grain. Merely looking at carry out analysis on our grains and also grains. You can tell if it's not good. Okay, so kunu is 400 naira, zobo is 300 naira. This
Compete with the prices of mineral drinks.
yes. One thing about this is the sugar is low and it has a very low glycemic index. Good for sugar is low. It has a low glycemic index for people that have diabetes, and also it is free from gluten. Good for people that are in gluten. From normal ingredients flour, yes. This is cornflakes. Yes. Extruder. Yes.
Well done. Thank you.
So there's no need of it.
Check my weight.
So we'll convert this for you, sir. Yes, sir. I want to check his BMI. Overweight, underweight, or
I have the mic now. Okay. Okay. I'm giving it to the Professor Jimon now. Okay. But the APC is not going to sign to you until they. Yeah. Give me the mic so that they can hear those who are speaking online. That's what I'm saying. And I said you should be very careful because this thing is tied to results. The result has been approved by the Senate. They want to use it. You have to be very careful. That's should be tied to results.
You know what? Yes, I agree with you. Where the support office happened in the country some years ago, the ball was not passed, and the project supervisor created the law. Okay. After we have signed this law, the ball was not saying we are going to the court. So we do see that we sign the clearance also somebody that will not complete this law.
No, that power is different. Even before they can be signed out, they need to submit a copy of their projects. That one is a solid ground to deny them that sort of something. This one is not a project. It's not a project. It's still work. Project is different.
Just like our practical.
This equivalent level of okay, somebody who has offended, who has degraded, who has and what has been corrected. We are going to call but you are not come back to submit.
No, but the truth is that if you sign it,
Yes. It's not to implement the correction and bring it back.
Yeah.
You see, the truth of the matter is that some of these students actually if you don't tie them to they won't come back.
They won't come back.
But I see a
very dicey situation.
Yes,
I
at the college. Yes, you want to have done that before
trying to advise the HOD that it should be very diplomatic about it. So, because some of them might be smart and say why they don't want to release him. This.
What is the level of the correction now? What is the level of the correction I want to see?
It's just a minimal something now. It's not that.
Can they do it within?
I don't know. Hello.
Something that they done in a day now.
Hey, Alpha. Hello. Hello. Bulewa, me.
That the students and
Dr. Dudu, please, are you in the console? Dr. Dudu. It's not there.
I don't want to see my
Okay. Okay. It's okay. It's okay. Do you need this? Okay, we. It's all right. Okay. Here. You are from FBI. Okay.
Good afternoon and welcome to the Intertertiary Technology Fair competition. In our midst today we have three individuals who will be presenting to us from three institutions. The first one is going to be from FUNAB by the former Vice Chancellor of Landmark University. And then we'll be having the next presentation from Federal Poly Ilaro, okay? And then the last one will be from Dr. Ajala from University of Ilorin. Welcome, sirs. Thank you, panel of judges, for being here. Thank you for giving us a bit of your time out of little time. Thank you so much, sirs. So without further ado, we'll call on the former Vice Chancellor of Landmark University, who is representing FUNAB, to start with his presentation. Thank you very much. And so after each presentation, the panel of judges will ask questions, and we'll be looking forward to you, panelists, responding accordingly. Thank you.
Good afternoon, all. I want to say congratulations to Bellstech University on this laudable feat, both for the convocation and that of this third fair. I'm going to be presenting on the projects that were carried out by some of my project students, especially with respect to the SDG 7, that is the Sustainable Development Goal 7 of the United Nations, talking about clean and avoidable energy. I have two of the projects here. The first one that I'm sharing is that of development of a miniature solar power system. And that was done by Salako AD and supervised by me from the Department of Agricultural and Bioresources Engineering, Federal University of Agriculture, Abeokuta. A brief introduction of the project. The project focuses on the design, construction, and performance evaluation of a tabletop, or what is called a miniature solar power system. And this is particularly suited for educational purpose, because to get teaching aids, especially in this day that the conversion of naira to dollar, or maybe dollar to naira, is not friendly at all. And so for us to buy some of these teaching aids from abroad, it will cost a fortune. So the thinking is, just like we had in the fair, in the program that we had just before now, talking about knowledge, skill, and experience. So we put our students to task, and we ask them to come up with this. So this one talks about a solar power system. The other one talks the solar and that of the wind. So here the project involved the integration of essential components such as a 30-watt solar panel, a 12-volt 4.5 ampere-hour battery, and a 500-watt inverter. It also has a controller for charge and also the output in terms of bulbs. This work emphasizes the renewable energy potential in the small-scale power generation and provides valuable insight into how solar system function under various operational systems. Can you imagine me teaching the students, and I'm just talking of solar panel, that may be a common feature But something like charge controller, I may have to be describing. Then before we talk of battery and before we talk of inverter, before we talk of battery, inverter, and that of both the AC load and the DC load. And that is what we have here. The drawing, anytime we are going into engineering drawing, we must have what is called design concept. So the concept here is having a solar panel, a charge controller, a battery, an inverter, an AC load, and a DC load. Then some calculations, of course, will have to be done before we are able to specify and have what is called BENE, the Bill of Engineering Quantity. And then, having done all of that, we went into the workshop, and so it is no longer at solar panel drawing stage. It is now having a solar panel. Then we have a microcontroller, the one that controls the charges, in order to supply it to either the AC or the DC. Then we have a battery, a small one. Then we have an inverter. So from this inverter, it will now work on the solar, the bulb. So we try to test it at various minutes, 0, 30, and 60. Of course, we have load, it's 115 watts. Then the inverter input is around 12.5 volts. And this was also produce the current of 9.58, 9.52, just like that. Then the output also. Then we have the power. And we're able to calculate the inverter efficiency. So this was used to light a 10 watt bulb, a 60 watt fan, a 45 watt PC charger test result. So the summary here is that the project demonstrated the viability and efficiency of solar energy for small scale power generation. Various tests that were carried out to evaluate the system performance under different conditions, and that includes lighting variation, battery charging and discharging, inverter efficiency, load handling capacity, and charge controller. So any student that is able to see this tabletop can also, when they go outside there, maybe at the industry level, they will have got an idea of how a solar system operates. The second one is on, the second one is on hydropower. Let me also give this basic foundation that what we are looking for when we use either the wind, the sun, the hydro, or steam, what we are looking for is motion. Remember Fleming's left-hand rule that when you have motion in a feed, current is generated. That is the basic thing that we want to transfer to the student. That either they use water, either they use solar, they use wind, they use steam, they use biomass. What we are looking for is something that will create movement or generate motion. And when that is done in an electric feed, definitely current is going to be generated. And that led us to the issue of the hydropower. That's the second project, and that was done by Bellstech TA. And this was done by harnessing hydroelectric power through an overhead tank. The project also seeks a sustainable and reliable alternative to conventional energy sources. The tabletop hydropower plant was developed using a water wheel, a reservoir, a small generator, especially to convert the kinetic energy from flowing water into electric energy. The system was designed for educational purposes, emphasizing the importance of hydropower as a clean energy, renewable energy source, and then with respect to the efficiency through design optimization. And just like we did for the solar, we have a design concept where the normal way this operates is to have a body of water that is dam at a relatively higher point. And when that is open, when we also know that such water will have what is called potential energy, that is calculated as mgh, the mass of water, the acceleration due to gravity, then over a height h. And once that one is open in a penstock, that potential energy is converted to kinetic energy through a movement. The mass of water is still the same mass of water, but now we have a speed of velocity. So the potential energy mgh will now be equal to kinetic energy half mv squared. That is the basic understanding. And once that one falls from a higher ground onto the rotor, remember we are looking for motion, something to rotate in an electric field. And once that one is done, then power is going to be generated. So the same, that is what we have here. Then we are able to now construct it after we have done a little bit of a calculation, and also have the penstock, the tank, and all of that. And so the test was also carried out at various heads. Then the voltage that was generated, the current, and then the power output. So the thinking is that we are able to produce up to 1.5 watts without load at a maximum head elevation of 0.96, and then the performance evaluation confirmed that the power output was directly related to the pressure head and that of but permit me also to say that I have a link for the video presentation of what the students carried out. Just give me just 1 minute there about. I'm trying to see if we can go online straight away to have that, because they made the presentation. I also sent the video presentation to the organizers, both for the solar power and that of the hydro. Once again, I want to thank you for this opportunity given us, and we wish you all of us all the best. Thank you.
Yeah, thank you, Prof, for this innovative and educative project. As a matter of fact, the design of solar energy is a continuous exercise, and at the moment it has solved several problems, particularly in the household problems, domestic problems. But the challenge we have with it at the moment is the applications of this in solving industrial need. Simply because of the heavy equipment and the machineries in the industry, there's these limitations of solar energy to actually engage this equipment. And I can see from your design, we are talking about the 12-volt panel. That may not likely solve industrial problem. I want you to put more light on it. What is your motive? What are you doing in using solar energy to solve industrial problem? Thank you. Hello? Hello, Prof. Are you online?
Hello? Hello?
All right. Are you online?
I should respond. You should respond to the question.
The thinking is this: you can't suspend something on nothing. If you hear me well, when I started, I said what we have here is for teaching aid, is a teaching aid model. Can you hear me?
Yes. Hello? We can hear you. Please go ahead.
Okay. What we have here is a teaching aid model. You know, at the level of the course that we take here, we were trying to introduce power generation, power transmission, power distribution, and that of utilization to
That's what we don't need. Especially to book on. Gbé síwájú ẹ̀, gbé sábẹ́ ẹ̀.
Network. So what do we do? From their end?
From their hand there, okay.
Can we tell another president? Huh?
Wait. It's not innovation or but at least we have been able to do something and it's for educational research. So
Hello?
Do that. You are talking of how do we take this thing to the industrial level? And I said, you can't suspend something on nothing. As far as engineering training is concerned, you have to start from the basic level. And even when you are talking of industrial equipment and all of that, you have to start from what is called the tiny tech level, the tabletop level, the small scale level, the medium scale level, before you now go on to the large scale level. So what we want to achieve with this project is first of all to sensitize the students. Let them have a basic understanding of the components of a solar power system, hydro power system, wind power system, steam power system, biomass power system, right from the basic principle of the difference between a generator and a motor. So what we are trying to do here is to first of all instill that knowledge on them, so that when they now go out there into the industry, they can always scale up. For example, what I've done even for this current session is to ask another set of students to improve on what these other one have done. Take for instance, for the hydropower, the level they took it was to release the water from the penstock to the water wheel and generate electricity to light the bulb. But the water has to be recirculated back. So I also ask another set of students want to work on that hydropower, scale it up, and also work on the solar system, look at those components, increase on their capacity. One of such is that voltage that you are talking about. So I think the level we are now is at the teaching age level. Thank you.
Yeah, thank you, Prof. My question is a very simple one, sir. I think what you have presented now addresses some environmental challenge which you have mentioned as a SDG 7. But I want to talk about design. The design of that, the first one, which is the solar power. Sir, are you with me, sir? Okay. So I want us to look at the design. How do we design the battery bank? What is the cost of that production? Then how do we estimate the load? So we should all know this, so that at least if we can even want to replicate it somewhere, we should be able to know how to design it. Thank you. Okay, thank you, Prof. My question is about the design of that solar power. So I'm just thinking now that at least in that design, we should look at the power bank, the battery that we are using. What kind of battery? How do we now go to it that we should use 12.5 or 4.5? Then the load estimation or drainage. How will it be draining? What time will it be used to power whatever machinery or anything that we are using it to power? And again, we should know the cost. You know, if the cost of producing it exceeds the one in the market, then it is not a good design. Thank you. Dr. Dudu, we are waiting for the next presenter.
Instead of duplicating it, we can just agree on something. That's what we are proposing.
Dr. Dudu, we are waiting, please. Okay, are you the one presenting, please?
Thank you, sir. Good afternoon, sirs. I'm standing on the already existing protocols. My name is Adegbola Oluwatosin Oluwabukola from Federal Polytechnic Ilaro, Ogun State. I'm here to do a poster presentation on the title which says Nutritional and Phytochemical Composition of Acrostichum aureum root. Acrostichum aureum root is a friend that belongs to the family Pteridaceae, and the leaf has been worked on previously, and it has been found to have a lot of antioxidant, antibacterial, anti-inflammatory activities. The shrub grows up to 4 meters tall, and it has adventitious roots that are visible at the bottom of the leaves. In some parts of the Indians, they apply the frond as antidote for venomous snake bites, while the fertile fronds and roots are used in treating syphilitic ulcers, pharyngitis, and diabetics. While the natives of Fuji, they use different parts of it to treat chest pain, fever, elephantiasis, and asthma, and also sore throat. Then the people of Badagry in Nigeria, they use the concoctions from the roots as newborn baby ointment, while the plant is used for the treatment of severe stomach ache and skin infection. Also, some parts of the European parts use the roots, the extract of the roots, to treat diarrhea, and it was discovered that it has anti-diarrhea properties. In all this, in all the works that have been done of the leaves and of the roots, there is that information about the compounds that are present in this particular route. And that is why there is a need for us to check the nutritional value, the phytochemical compounds that are present in it. And the first thing that was done is to check the nutritional values. We checked for the crude ash, for the crude fiber, we checked for the moisture content and other proximate analysis. And then what was done again was that we prepared 4 extracts using 4 different solvents, which are, we used ethanol, we used water, we used ethyl acetate and N-hexane. The roots were gotten from a mangrove part of Unilag in Lagos, and it was also authenticated at the botany department in Unilag. So it was dried and blended and soaked in the different solvents for 48 hours, and it was filtered before it was taken for the phytochemical screening. For the qualitative, next, sir. Yeah, thank you. For the nutritional composition of the roots, it was discovered that it has a very high percentage of carbohydrates, and followed by crude fiber, and followed by moisture content, and so on and so forth like that. And this shows us that the part of the plant root has a lot of nutritional values. Also, for the phytochemical screening, we did the qualitative first, and the qualitative, the next slide, sir. The qualitative results showed us the presence of some secondary metabolites. We have the alcohol, which is the ethanol, then we have the ethyl acetate and the aqueous. So these are the metabolites that were found, and it was discovered that some of the metabolites that were found in the ethanol extract are not found in the ethyl acetate extract. Likewise, also the aqueous extract. So in alcohol extract, alkaloid was found in all the extracts. Alkaloid was found, and tannin also was found. In fact, tannin has the highest percentage in the quantitative. Then for saponin too was found. And then when we go to phenol, we can see that in ethyl acetate, phenol is negative, and we further moved to checking for the quantitative, for the quantity of these metabolites that are in the root extract. Next slide, sir. Now, for the aqueous extract, we found that tannin has the highest percentage, the highest value in all the extracts. In aqueous, we have 0.7, in alcohol, 0.8, in ethyl acetate, 0.7. And earlier, while I was doing the introduction, I said there was a part of the, in Europe, that they did a study checking for the anti-diarrhea activities of the root. And it was concluded in that study that the root extract worked, probably because of the very high content of tannin in the root. The next slide. This is the chromatogram of the compounds that are found in the different extracts. And out of this, we have over 60 compounds that were being found in the extract. And out of it, I was able to bring out few of it. The next slide, please. Few of it, bringing out the food application, the industrial application, and the pharmaceutical application. And it was found in this aqueous extract that talate has the highest percentage area, and Talent is a very good plasticizer in the food industry, in the pharmaceutical industry, for the for this the plastic or the rubber that is used for drip. So it's a very good compound for it. Then we have the vinyl ether and so on and so forth like that. We have the maltol, which is widely used as a flavor enhancer in the food industry. And this maltol is used in pharmaceutical companies, especially in children drugs, to enhance the taste. Then the next slide, sir. So these are also few of the compounds that are also found in the aqueous extract. Next slide, sir. So moving to the compounds that are, next slide, sir. So these are few of the compounds that are found in the N-hexane extract, where we can see that we have the octyl decamol, we have the transfernesol, and all they have a lot of good benefits in the industry, both in the food application, in the pharmaceutical application, and in industrial application. Some are used as plasticizer, like I said. Some are used for in the food industry. They are used to enhance flavor. Some are used for as preservatives. So the next slide, sir. Next one, sir. Next slide, sir. Next one. Okay, thank you, sir. This is for the ethyl acetate extract. When I said that we have over 60 compounds, I mean individually. For the aqueous extract, for the ethyl acetate extract, for the ethanol extract, and for the water, which is the aqueous extract. And in this ethyl acetate extract also, we have hexadecanoic acid that has the highest, and which serves as a good antioxidant in pharmaceutical industries. The next one, sir. For the ethanol, next one, sir. For the ethanol extract, yes, which is the last. For the ethanol extract, we have a lot of compounds, and most of the compounds that are found, like I said earlier, in the aqueous extract, the compounds that has the highest percentage area is the phthalate. And in ethanol extract, we have the phosphora. And phosphora is a very good antioxidant. It is used in pharmaceutical, it is used highly in pharmaceutical industries. Next slide, sir. Also in ethanol extract, we have maltol. Like I said earlier, what maltol is being used is used in food industries as a flavor enhancer, in the pharmaceutical industry too as a flavor enhancer, especially in the manufacturing of children drugs or any drugs that needs the taste to be that needs in all these syrups. So, and also it is very good in industries. The next slide, sir. So concluding this, in conclusion, next slide, sir. In conclusion, this particular work was targeted at looking at Acrocisium aureum as a means of using it for all the other, instead of using standard drugs. So there has been works that this route has been used. Like I said earlier, it has been used for diarrhea, and it has also been used to check the safety and other things. But now, what we did on this particular project is to check what the roots contain, what are being useful in both in all the phases of industries, and the data got in suggested to us that this particular root is rich in nutrients, considering the fact that it has a high concentration of carbohydrates, of fiber, and so on. And also the phytochemicals that are found, the secondary metabolites, and the other compounds that are found in the GCMS analysis. They are useful nutraceutical, pharmaceutical, and industrial applications. Thank you, sir.
Thank you very much, madam. We quite appreciate the efforts that have been put in this presentation. However, number one, it's expected that this be a poster presentation. But what we have presented before us is not a poster presentation. Okay, this is the poster. Oh, okay. Yeah, if we go by this poster, the readability. But the basic question I want to ask, what was the native or local name for this plant that you are presenting the roots to us? Is it what we can find?
The English name is mangrove fern, F-E-R-N. That's the English name, sir. Yes, sir. I've been trying as much as, sir. Yes, sir. The English name and the native names. So I've been working on the traditional names, the native names, but I've not gotten it.
What do you call this plant?
Go to Badagry there. They have a name.
It's called
Ogun State. It has a local name.
You are not supposed to talk.
No, I'm just giving an insight.
Don't. If you go, you not be better. Okay, you want to ask your question? Then ask your question. Okay, you have not. No, if you have not. Okay. The application, because the title is saying the nutritional. Are you now suggesting that this plant, the root, we can take it as human being, cook it and eat? Or how do we use it? Because you're saying that it contains a lot of carbohydrates. And here we are, we need energy. So how do we get that used?
So what I'm trying to bring out is that for the industry, for the food industry, the pharmaceutical industry, and other industry that can use the compounds that are found in that root. Not that we can eat it directly, because if considering what was found in the compound, talate is a bit dangerous to the body. And looking at the aqueous extract, that's soaking the root in water and drinking it. That means that brings out talate in that root. But soaking with other solvents, talate is not present. Talate is, we have other compounds. It's for the industry, sir. Yes, sir.
For the industry, for pharmaceutical company, for household,
So what we are saying is that, sorry, thank you very much for that question. Well, even though it has a lot of, like she has mentioned, the presence of phthalates make us have some cautious, opinion about it. But not that notwithstanding, we as chemists, we can actually, that's why she fractionalized, we can separate out the compound, excluding the phthalates. And with that, without high carbohydrates, that means it can actually be found application in feeding of fish. If, for example, human cannot take it, because this is something that grows inside water, so we can actually get those carbohydrates, feed it to fish. If we are not, we are afraid that it's going to, after separating some of the poisonous things inside the plant.
Thank you very much for the presentation. Yeah, my question is on your literature. The first time you said this root contains about 82% carbohydrate. Carbohydrate, good. And while speaking, you said it can be used to treat diabetes. Be very careful. Recheck, that is one. Two, you talk about glycosides, and you said the glycoside in that root is negative. So how will it be negative when you have high percentage of carbohydrates? Please recheck. And finally, my last question is about the pharmaceutical use that you talk about. You see, just because you have done this work will not mean that pharmacists or pharmaceuticals can use it. Because when you started and you mentioned compound present, I was even thinking you are going to mention the heavy metals or the toxic metals that is in that would not be able for the pharmaceutical to use it. Please just include it in your work. Thank you.
Yeah. Thank you, madam. Well done for this noble presentation. As a matter of fact, I want to sincerely appreciate your courage and your focus, because I could remember you were here last year. You were here last year. You didn't come first, and you are here again this year. That is commendable. However, you have done justice to your presentation, no doubt about it. But I'm worried about the topic, number one. Because your topic says nutritional and phytochemical. You see, when the topic in any presentations we give, it hit the heart of your listener. Yes, towards expectation. Meanwhile, your presentation is more of industrial and pharmaceutical applications of the plant. We are expecting, when you are talking about nutritional, we are expecting nutritional value. Yes, how this can enhance the intake, individual intake, and all that. Now, we were made to know now that it is not at a moment that the plant is not edible, and that certain thing has to be done to actually get the benefit therein. But the impression you have created, that is our expectation, that we are looking at the additional value of this plant. And so it is more, probably you need to go and sit down and recast your topic. Yeah, your presentation is a little, yes, from the topic. Now, two, go to your table 3. Please, I need to point your attention to something in your table 3. Can we still have it?
Dr. Dudu, can we have table 3?
Okay. Yeah, but it's tiny. But let me point your attention to it. Some of your findings, yes, that table talks about, I think, phytochemical analysis, isn't it? Yes, I could see some of your results. Some of them are up to 6, 7 significant figure. Yes, there is no uniformity in your result. Yeah, some has about 2 significant figure, some 3, while some up to 7 or 8 significant figure. Please, you need to work on that. Whatever you are presenting, there must be a uniformity in your presentation. You can see it. You can see it. All right. Then finally, what is the significance? It's a question now. What is the significance of this your work to SDG?
Well, let me also commend your brilliant presentation. I want to be very sure I was seeing well. When you display your references, I saw Wikipedia there. Wikipedia. Am I correct? Wikipedia. Please, you need to, it's not a credible source of scholarly information. You need to check very well.
You can respond to that. The SDG application.
Thank you, sir. This particular work is about how it can be related to sustainable development goal. Is that one is considering all the applications, both all the industrial applications, whether the food or the pharmaceutical applications, considering them, if we are able to make use of these compounds, since this particular plant is readily available, if we are able to make use of it and channel it at the right resources, we can be able to be getting most of the things that are being brought from outside the country and are being used in the industries. Okay, yes, health, sir. Health is health. It's health, sir.
No, other thing.
Okay, ma. Like they said, you have tried. I do understand. But all these corrections, I was looking at your analysis. Although I'm not a scientist, I tend to love the way you went through the literature. But there is something I want to point out. In your conclusion, you must always refer to your topic very well. Draw people's attention to your topic and the relevance to, like the first person that asked the question, I think it was very specific. The relevance to pharmaceutical industry. I don't understand. The relevance to, you talk about nutrition, of what value does it have on we that will consume this very particular root? So thank you so much. God bless you.
Oh yeah, I should go. No, go down. It's not on. No. It's not on. No. It's not on. It's still the Bells University is in my shop. Okay, sir, please, can you go ahead, sir? Can you breathe? Can you just talk out? Speak out.
All right. Using the WhatsApp, right? Or hello? Are you seeing my screen?
Yes, we can see your screen, sir.
Can I be speaking on?
Yes, you can speak on.
Okay, good afternoon, everyone. Please permit me to stand on the existing protocol. I'm here to make a presentation on the absorption of lead and chromium ions from electroplating wastewater using plantain stock modified by amorphous alumina developed from waste can. My name is Ajalo Lawale. I'm from the Department of Chemical Engineering, University of Ilorin. Water is essential for life, and the Earth's surface is made up of 70% of water. But it's unfortunate that the available water for domestic and drinkable is not available for human beings. We have observed that a lot of industrial development that has affected our water bodies by way of discharging their wastewater into the water bodies, which has led to toxicity of water, pollution of water in different ways, and such make water not available for human use. From industrial wastewater discharge, we have observed that electroplating industry also contributes significantly to this pollution of wastewater. We have observed that there are high level of copper, iron, nickel, chromium, and what have you in the electroplating wastewater. We have observed that some of these heavy metals causes a lot of diseases to human beings, like dermatitis, nausea, chronic asthma. We have also observed that cadmium is present in high quantity in electroplating wastewater, and this cadmium can cause kidney damage, renal disorder, and human carcinogens. This industrial wastewater before discharging it into water bodies. From literatures and research, there are so many numbers of methods for wastewater treatment. We have ion exchange, we have electrochemical method, we have membrane method, we also have absorption method. Absorption method is so popular because it is cheap, easy to come by, it is also reusable, and it will not cause nuisance to the environment if properly managed. So this study actually developed that absorbent for absorption from plantain stock and aluminum waste can, in which these two important feedstock for absorption development, they are also waste products causing nuisance in our environment. These are waste pollutants that we are developing into a product that can be used to treat electroplating wastewater in order to absorb the lead and chromium that is present in electroplating wastewater. Methodology. The raw plantain stock was prepared by way of beneficiation. The waste can was also prepared by way of digestion and precipitation to produce amorphous aluminum from that aluminum waste can. And the two were co-impregnated. Jesus. Am I on?
we can hear you, sir.
All right. So the two waste materials were actually co-pregnated into developing an absorbent that can be used to treat electroplating wastewater. In this study, we carried out patch absorption study. The absorbent developed were also characterized, and some variables were considered that could affect the absorption process were considered for study. This is the formula that we use to calculate the absorption capacity of our absorbents to determine the efficiency of pollutant removal, particularly lead and chromium from the waste water. The kinetic study were also studied. 3 models were used: the first order model, the second order model, the LOV. These were to help us to determine which kind of absorption will take place when these absorbents will be used to absorb lead and chromium from electroplating wastewater. Whether it's going to be visorption, chemisorptions, or it will be a mass transfer dilution process. Absorption isotherms were also carried out. Now, from the result of the study, before the plantain stock were developed into absorbents, we determined the thermal stability of the plantain stock, and we could observe that the plantain stock can withstand thermal temperature up to 800 degrees Celsius. This figure 2 gives us the insight. We could see that the water was removed as 10% of water were removed at 300 degrees Celsius, and at 400 degrees Celsius, the other impurity present or the other organic matter present in the plantain stock were also removed. So after developing the absorbent, we were able to compare the chemical characteristics of the chemical profile of the raw materials, which is the alumina, the raw plantain stock, and the developed absorbent. And from the SRG analysis, we could observe that there was interaction between the alumina and the raw plantain stock, as the chemical compound present in alumina were also present in the products, and the chemical compound present in raw plantain stock, which is organic compound, were also present in the absorbent developed, meaning that there is actually co-impregnation of the two materials to develop a new product of absorbent. The functional group were also carried out, and from these interactions between the two raw materials to give us absorbent, we could see that the functional groups like CH3, COOH, CN that were present in the absorbent, they are actually important organic compounds that can help in absorptions of heavy metal from wastewater. And in this case, we are looking at lead ion and chromium ions. The morphology, the surface morphology that was carried out also showed that there was significant improvement from the two raw materials. The figure A is the raw plantain stock. From that figure, no pores was discovered, no pore was seen. And we could see that there are some pores in the alumina developed, which is figure B, figure 5B. And when the two are combined together, we could see that there are pores and there is impregnations of the plantain stock on the surface of alumina. And this to say that this could be a good absorbent for the treatment of industrial wastewater. So this BET analysis also confirmed the result of the CEN, which shows that the aluminum plantain stock, which is our absorbent, actually have larger surface area. Probably there is a combination of the surface area of the raw plantain stock and alumina. And also show that there is a significant increase in the pore volume and the pore size. These are characteristics for absorption process. The industrial electroplating wastewater was also characterized before and after absorption, and it was compared with WHO standard and USEPA standard. When the wastewater was characterized, we discovered that lead, iron, chromium, nickel, zinc, and iron, as well as copper and cadmium, were beyond the recommended standard of WHO. So the raw plantain stock be an organic material, and the developed product, which is the adsorbent from the raw plantain stock and aluminium, waste aluminium can, were tested for the absorption. The result shows that aluminum plantain stock absorb heavy metal ion better than the raw plantain stock. This shows that the raw plantain stock may not be so effective to treat this particular industrial wastewater unless we can modify it with other chemicals, and in this case modify with alpha alumina. However, we discovered that nickel was not well absorbed by the aluminum plantain stock absorbent. Probably there is no affinity for nickel from the absorbent does not have affinity for nickel. Hence, nickel was not considered for further study. And we observed that for the APS, which is aluminum plantain stock, many of other metal ions present in wastewater were significantly reduced, and they were reduced below WHO standard and US EPA. So from this study of investigating the metal ion concentrated in electroplating wastewater, we could observe that lead, iron, and chromium are still beyond the standard, except nickel that was not significantly removed from the preliminary study. Hence, only lead and chromium were taken for further study. From the effect of the absorbance dose, we observed that absorbent dosage of 1.25 significantly removed the 2 metal ion. For the lead, about 90% was significantly removed when 1.25, and beyond there was no significant removal, probably because there is oversaturation of metal ion. There is oversaturation of the absorbent in the medium. When contact time was also investigated, we observed that the more the time of absorption, the better the absorption capacity. So we were able to significantly remove more metal ion at 180 minutes for chromium and lead ion. So when temperature was also investigated, we observed that 75 degrees Celsius 60 degrees Celsius favor the absorption study. For the 2 ion, at 45, it was only chromium that were significantly removed. But at 60 degrees Celsius, we could see that both chromium and lead were removed. Then we go further to carry out the investigation on the kinetics models, the first order, second order, and intra-particle dilution model. From this study, we could see that the R-square value was so significant because it's closer to unity for first order kinetics. The same thing was observed for second order kinetics. The same thing was also observed for intraparticle dilution. However, we discovered that the second order kinetic model were closer for the 2 metal ion, were closer to unity than any other. Hence, second order kinetics was considered to best describe the absorption of lead ion and chromium ion from electroplating wastewater onto aluminium plantain stock absorbent. Therefore, we can easily conclude that pseudo second order, which is chemi-sorption, describe the kind of absorption that takes place between the absorbent and the adsorbate. These are the data for the analysis that confirm that there is the graph, the model, and the experimental data actually they are closer, which shows that the data is tending towards 1. for the isotherm, you could see that the Ladmo isotherm, friendly isotherm, Tenkin isotherm also shows that the three models considered also show that the R-square value closer to 1 for each, particularly for the Ladmo, the lead ion is 1. The R-square value is 0. For the R-square value is 0.978 for lead, while for chromium is 0.993. So we can confirm from this analysis also that Freundlich, because for Freundlich we have 1 R-square for Freundlich for chromium, and we have 0.960 for lead. So that Freundlich also describe the absorption process better than some other, even though the other models also perform well, but from among the three models, Freundlich seems to perform better. This is a graph that shows the models and the experimental data, how they align with each other. The thermodynamic study also confirmed that the process is also actually endothermic because of the negative value of the delta G. And the delta S also shows that there is the reaction is spontaneous, and heat is actually required for this absorption to take place because of high value of delta E, that's the entropy. The usability was studied, and it was observed that it was at cycle 7 that it was at cycle 6 that the chromium dropped. The absorbent will not perform well at cycle 6, so it could be recommended that this absorbent can be suitable for repeated use for only 5 cycles. And when it was regenerated, the performance is actually closer to the original raw material. So in conclusion, the raw plantain stock and aluminum waste can were effectively converted into an absorbent, which offer distinct advantage and also has strong absorptive capacity. The characterization study also confirmed that the absorbent is a good material for absorption process. This study also shows that lead ion and chromium were significantly removed from the electroplating waste water. Therefore, the aluminum plantain stock was sufficiently used for the sequestration of lead ion and chromium ion in electroplating wastewater. These are my few references. I want to say thank you for listening.
Thank you.
Dr. Ajala, thank you so much.
Yes, sir.
Now, please, can you mute your mic on WhatsApp?
Okay.
Yeah, Doctor, thank you for your presentation. It's a very nice and articulated presentation, which we all like. But my question will now go back to your methodology again and the mathematical model that you have used. That is the first one. You know, when you talk about the SODO, we know what it means. And it is not well expressed, which you have to teach us again. And in mixing this aluminum, the aluminium, how do you go about it? What is the proportion? The proportion of the aluminum that you mix with the plantain stock, we will need to know. And again, maybe it is fractionalized. So you have to tell us so that we know the best combination that we can use to do that. And finally, I would like to ask, this your research now or your presentation, which of the SDG goals are still addressed? Thank you very much.
Thank you, Doc. Are you still online?
Can you now speak, please?
All right. All right.
Can I respond now?
Yes, you can.
All right, thank you very much, sir. I'm very grateful for the comments and the observation. The study investigated the two raw materials in different proportion. What we did was to consider them in molar ratio. So we investigated 1:1. We investigated 1:1, 1:1. No, sorry, 1:1, 1:2, and 2:1. And we observed that the 1:1 ratio in terms of molar ratio is raw plantain stock to alumina. So when it is 1:2, it is one raw plantain stock, and 2 alumina. Then the other one is 2 raw plantain stock and 1 alumina. And we concluded that it was 2:1 of raw plantain stock and 1 alumina that performed better. This was carried out in a preliminary study, and when it was confirmed, then we went ahead to carry out further study. I think SDG 7, where we talked about clean water, if I'm not mistaken. That's the SDG goals that this aspect of the study talked about. I don't know if I've answered the questions.
Thank you. Yeah.
Thank you very much, sir. So can you mute your mic so that the next question can come?
All right. Thank you for this presentation. You have done well. I have a small question for you, particularly in the selection of plantain stock as your absorbent. You have not convincingly discussed what informed you for the use of plantain stock. And I want you to put more light on that. Then secondly, in your figure 2 and figure 3, your aluminum oxide. Yes, it's not, you didn't take note of it. It's like your 3 and 2 was not properly positioned. Yes. So kindly, attend to this question. Thank you.
I seem not to get out of question 2 very well.
The question
I
2,
think he's talking about.
yes, it's an observation.
Okay.
Yes, it's only the first one that is a question. The second one is just an observation about your aluminum oxide.
Okay. All right.
You can go ahead.
Well, from literature, agricultural residues has been confirmed to be a good source of adsorbents. So what we are only doing now is to see which one we have affinity for, which of the agricultural residue could have affinity for a particular heavy metal ion. These agricultural residue mainly they are organic materials, and we are aware that they contain different functional groups. However, each of the functional group that we have could be responsible for absorption of different metal ions. So in this study, if you look at the presentation, you will see that this raw plantain stock modified with alumina will not even remove nickel. The implication is that it does not have affinity for nickel, perhaps because of the organic compounds that is associated with raw plantain stock. I need to say that the reason why this study was carried out is because raw plantain stock is also causing nuisance to the environment, being a residue from agricultural produce. And now we carry out the study from preliminary investigations to the main study. We discovered that the composition of raw plantain stock is suitable to absorb lead ion and chromium ion, not only from electroplating wastewater, but from any industrial wastewater that is laden with any of these metal ion. So generally, agricultural residue, they are good raw material for absorption process. So plantain stock is one of them, and we just pick them and try to see which of the metal ion can the plantain stock be effective, who effectively handle from industrial wastewater. So thank you, sir.
Thank you. Yeah, you are highly appreciated. All right.
Thank you, sir. I hope I'm still on.
Dr. Ajala.
Hello, sir.
Dr. Ajala, thank you so much for your presentation. We appreciate you. And
thank you so much.
Yes, sir. You will hear from us. We allow the panel of judges do their thing, and then we will get back to you, sir. Thank you so much. Thank you so much.
Thank you so much. I'm sincerely grateful for the opportunity, and sorry for the technical issues here and there. So wish you best of luck. Thank you so much, sirs.
Thank you. Thank you so much. Thank you. So thank you so much once again. We are grateful to the panel of judges, and I think we had a very nice outing today. We had about 3 presenters, 3 or so. Yes, so we thank God that we're able to achieve that despite the technical glitches and here and there. So thank you so much, and we look forward to seeing you all next year. And from us here, we thank you so much, and we look forward to seeing you soon. We'll continue live coverage of the event, of the exhibition outside. Thank you so much.
Six.